Hey guys, so this is just a review for the test that you have to take. This is your final grade, and I will put it in the gradebook as a test grade. So just make sure you do the best on it. You can take as many times as you want. I'll change the password after 3 tries. So the first one says solve using elimination. So I'm going to get rid of a variable. The easiest one to get rid of is the x. So I'm going to multiply this equation by 2. So I'm going to rewrite the original one, multiply the other equation by 2. So I get 3y equals negative 12 divided by 3. Y equals negative 4. Now you can plug that into either equation. I'm going to plug it into the bottom one. And then you're going to have to write your answer like this. So that's using elimination. The next one is using substitution. So these are just problems that I pulled from the test. The easiest one is to solve for x. So x equals negative 4. You can plug it in. So now I have 4 times negative 4 minus 6y equals 18. Just simplify your fraction. And that would be your answer to that one. So that's substitution. So that's questions 1 and 2. Question 3, there's 3 parts. Vertical asymptote is the bottom of the fraction, so set it equal to 0 and solve. So you're going to have 2 of them. You're going to have a positive 5 and a negative 5. Horizontal asymptotes is based off the degrees, so the degree down here is 2, the degree up here is 0. If the degree on bottom is bigger, it's automatically y equals 0. And when it says sketch the graph, you're going to have to plug in points. So I'm going to plug in 0 for my x, 1 for my x, 2 for my x, 3 for my x. So as example, if I plug in 0, I get 1 over negative 25. And you would do the other ones and solve for the other ones. So plug in and solve it. Solve the rational inequality. Remember, you want to get rid of the denominator if you can, or move everything to one side. Just kind of depends on the problem. So I'm going to subtract the 4x over. And then I'm going to multiply it by x plus 3 on top and bottom. So now you're going to get this 16 minus 4x squared minus 12x all over x plus 3. And then you're going to have to factor it. I would factor the top first. You don't worry about the bottom. So look at all the values that give you 0. You have negative 4, 1, and negative 3. All right, they're all going to be open circles because it's greater than. The bottom one is always an open circle. And you do your test points. So the easiest one is to plug in 0. When you plug in 0, you get a negative times a positive times a negative over a positive. So that would be a positive over a positive. Is 0 going to be greater than a positive number? The answer would be no, so I'm not going to shade there, so I'm going to shade this way and this way. So your answer is -4, -3, union 1, 2, infinity. Next problem, it says indicate which of the following four graphs. They're going to give you four graphs to choose from, guys. You're worried about the base. So this means decay, so it's going to go like this. And it's going to have a y-intercept at 0, 1. Alright, if it was growth, so if it's anything greater than 1, so example, if I had 2 to the x, it would look like this. It'd still have that y-intercept at 0, 1. So you're just basing off that. Find the inverse. This is what we are doing today. So to find the inverse, you need to find the determinant first. So that's 24 minus 24. So I did -6 times -4 minus 6 times 4. You get 0. If you have 1 over 0, there is no inverse. And you'll know more about that after today's lesson. Elementary operations. To get rid of the log base, you make the base of the log the exponent base on both sides. That gets rid of this, so then you have x equals 125 to the 2/3. Just type it into your calculator. You're going to get 25. Find the x-intercepts at which f crosses the x-axis. Express the intercepts as ordered pairs. So on this one it says find the x-intercepts at which f crosses. So crosses would be anything that's odd. So you're looking for odd exponents. So my answer to this one would be 2, 0, and 1, 0. It's got an exponent of 1. The degree and y-intercept. To find the degree, you take the number that they give you to the exponent, and you multiply all of them together. Just make sure you watch your signs on this. So this would be 16 times -32 times -1. Whatever that number is, I don't have a calculator. You put 0, comma, whatever it is. Your degree, you just add the exponents together, so my degree would be 8 on this problem. The ones that flatten out are anything greater than 1. So exponent greater than 1. So the exponents that are greater than 1 are -4, 0, and 2, 0. Alright, so that's the answer to that three-part question. This one, number 9, you're just plugging into the equation. They're going to give you a value, they're going to give you a rate, and they're going to give you a time. I just plug it in. So 22,000 to this equation times 1 plus 0.025. Get it right as a decimal to the third. You would do this first into your calculator, take it to the third power, and then times 22,000 to get your answer. Number 10, properties of logs. Alright, so if the 4 is out front, that means I'm going to multiply it by the log. So I'm going to have x to the 8th, y to the 12th, times 1 over x to the 7th, divided by y to the 3rd, which is the same as multiplying 1 to the 3rd, or 1 over y to the 3rd. So it's going to look like this. X to the 8th, y to the 12th, over x to the 7th, y to the 3rd. Get your answer, subtract your exponents, and then you put the log out front. Determine the order. That just means the dimensions. So in this case, it's 2 rows by 3 columns. So that's what you would write, 2 by 3. That's what order means. Determine the value of C33. That means you're going to go to row 3, column 3. There isn't a row 3, so you're going to put none on that one. And C22 means row 2, column 2. So row 2, column 2 would be -13. That would be your answer. That's how you do those. Elementary operations. So I'm just going to rewrite these in the same exponent base. So this would be 4 to the -3x equals 4 to the 2nd. Because 4 to the 3rd so then I just rewrote them by multiplying. Your bases cancel, so I get -3x equals 2 divided by -3. x equals negative 2/3. 13, you're just going to multiply them all by 4 and then add them. So multiply both those by 4. That's what it tells you to do. Do that first. So I got negative 20, 4, 24, negative 4, negative 32, 8, plus, that's 36, negative 16, 20, negative 20, negative 20, negative 32. So now you add them. I would add negative 20, 36, 16, 4, negative 16 would be negative 12, 24 and 20 would be 44. Negative 4, negative 20 would be negative 24, negative 32, negative 20 would be negative 52. And that would be your final answer. Next one, use properties of logs. This one you're just going to rewrite it. So it's going to be natural log of 9 plus 2 natural log of x because the exponent goes out front, minus, because you're doing division, 7 natural log of y. That's how you would do those. So that's expanded form. Construct one that is 5th degree. 4 is a 0 multiplicity of 3. So that means I would do the opposite sign. 3 would be the multiplicity, so that's your exponent. The only other one is a negative 3, but I got to have a 5th degree, so I need my exponents to add up to 5, and then your leading coefficient is 3, so you put the 3 out front. That's how you'd write that. Vertical asymptotes, again, you're just worried about the bottom. Set it equal to 0. So we did one like this before. There's 2 questions like this. Horizontal asymptote or oblique is based off the degree. If it's the exact same, you do division. So I get y equals negative 1. The only time you do long division is if it's 1 more on top than it is on bottom. And then you'd have to do long division. And the last one, it says identify forward pairs. Guys, just plug in any number for x except for negative 7. So I'm going to plug in 0, 1, 2, and 3. So I plug in 0, you get negative 10 over 7. Just random as fractions, guys. Use system and equations to solve the problem. So it says an investor decides to invest some cash in an account paying 14% annual interest and to put the rest in a stock fund that ends up earning 6% over the course of the year. The investor puts $1,800 more in the first account than in the stock fund. So we're going to say the first account is X, Y is your stock. So if he's putting $1,800 more in the first account, so $1,800 so X minus 1,800 equals your Y, equals your second account. And at the end of the year, the total interest is this. So I'm going to take 0.14 times X plus 0.06 times Y equals 520. Now you have a system. You can use substitution or elimination. I would use substitution and sub this in for your Y. So I'm going to plug that in for that Y right there and then solve it. I'm not going to take the time to solve that one because the video has to be kind of quick. Here's the hardest one. This is the one I want you to pay attention to the most. So the first part is the only hard part about it. So there's going to be 3 parts. And again, the first part's the hardest part. So here's what you do. You take log of 1/2 divided by your half-life. You get an answer. Then you do this. You take 10 to the power of your answer to get your A. And you're going to round it to 6 decimal places, so whatever that is. So now you're going to take that answer and you're going to plug it in. So it's a 12-gram sample, 41 seconds. So it would take 12 times A, which is what we did in the last problem, to the 41st. And you can just type that into your calculator and do the same thing on part 3. 12 times A, which we did in part 1, to the 79th. And on the test, it should have a look at your previous step answer. But this is how you do this one. This one's very important to understand. So log of 1/2 divided by the half-life, and you take 10 to the answer to get your little A. Determinant, 18 times negative 25 minus negative 50 times 9. So whatever that is. I don't have a calculator, so I can't really do it. Last one, it's very important that you rewrite this. So e to the 7 over 8. Nice thing is natural log and base e cancel each other, so your answer is just 7/8. So that's a quick